Hello, and welcome to video 4 of the chemistry lecture series on topic 1, an introduction to chemistry. Today's topic is dimensional analysis, the act of converting one unit of measurement into another completely unrelated or completely different unit of measurement. This is the final video on topic 1, and as a result, there will probably be a short assessment or an assessment of some sort after the video. As you're probably thinking to yourself, why is he talking? So that being said, let's go ahead and get started. So what is dimensional analysis? Short and sweet, it's converting one unit into another. Typically, we look at that as centimeters to meters, millimeters to meters, milliliters into liters, kilograms into grams, that type of measurement. In a more formal way, dimensional analysis is the act of converting one unit of measurement into another through the use of a conversion factor or multiple conversion factors. Dimensional analysis is probably the most important skill you're going to learn in this class. Whether you use chemistry in the future, whether you're a cook, a baker, a businessman, you're going to use dimensional analysis. You have to know how to take numbers in one form and convert them into another that you're going to be able to use. Cosmetologists do this when they're mixing up their hair dyes. Bakers do this when they're reducing or expanding recipes. Accountants do this when they take bank accounts and apply formulas to figure out interest or things like that. All of these processes are dimensional analysis. Now, to perform dimensional analysis, you need to use a conversion factor. A conversion factor is an established equivalency. It's something we know that is equivalent to the unit we are working with currently, and it allows us to convert from the unit we're working with into the unit we want. The most common conversion factor used in chemistry relates to the mole, which is an established constant of count. In real life, a conversion factor might be converting one unit of measure into another, or a price with a product into a value. As an example, a conversion factor you might use on a regular basis might be price per pound. So let's take a look at that. If apples are, 30 cents a pound, we can convert that into a conversion factor. We know that we can get 1 pound of apples for 30 cents. Using that equivalency, we can create a ratio. We know that 1 over 0.3 is equal to 1, or vice versa, 0.3 over 1 is equal to 1. And it's important that we carry our units, because if you don't, this just looks silly. It looks like a math problem that makes no sense. You have to carry the units. And this is how we use conversion factors. This is how we create conversion factors to solve dimensional analysis problems. If apples are 76 cents a pound and Jimmy has $5, how many pounds of apples can he buy? This is a dimensional analysis problem. If we know that Jimmy has $5 and we want to know how many apples that will be, we take our equivalency, 76 cents equals 1 pound, and we establish a ratio. We multiply through by that ratio. So we take our unit we want, pounds of apples, so 1 pound, and we put that on the top of the ratio, and then we take the unit we have, dollars or cents, and we put that on the bottom, so 0.76. And we just multiply through and cancel the units. So we cancel our dollar signs. That leaves us with pounds, and we multiply through to get 6.578 pounds. Now, we'll go ahead and round that since our significant figures were 1. So we can get 6 pounds of apples for $5. Or you could possibly round to 6.5. Now, in keeping with the theme here, we know that Jimmy will have 6 pounds of apples, and if the average weight of an apple is 2 ounces, how many apples will Jimmy end up buying? We can take our 6 pounds of apples, which we know he has, and we can use another conversion factor. We know that 1 pound is 16 ounces, so we want this in ounces, so we put that on the top of our ratio. We know that's 1 pound, that's our equivalency, so 6 pounds times 16 gives you a total number of apples of, let me do the numbers real quick, 16 times 6, 96 apples. So we've taken our $5 in this original problem right here and converted it into a number of apples through 2 conversion factors. Here we have another problem that involves some sort of dimensional analysis. If Bob has 1 foot and 6 inches of wire and needs 4 meters of wire to complete his circuit, will he be able to? This is a more basic dimensional analysis problem that involves units of similar measure but different calibration. So we have 1 foot, 6 inches of wire, and we need 4 meters. So the way to convert this is we need to convert our 1 foot 6 inches into meters. First and foremost, we need our 1 foot 6 inches in a similar unit. It's easier to convert the larger unit into a smaller unit, so we know 1 foot is 12 inches, so then 12 plus 6 is 18 inches. Okay. We also know that for our first conversion factor, because we're going to use more than one, 1 inch equals 2.54 centimeters. With that conversion factor converts our English unit into a metric unit. So we have to use that first. So times what we're converting from goes on the bottom, what we're converting to goes on the top. 18 times 2.54 over 1, and that gives us 45.72 centimeters. Now, we don't round yet because we're not to our final answer, and we don't need to worry about significant figures yet. So, we're at centimeters. We need meters. The way to convert from centimeters to meters is we use another conversion factor, and we know that 1 meter equals 100 centimeters. Okay? So we, once again, multiply through by our conversion factor. We put what we're converting from on the bottom, 100 centimeters, and what we're converting to on the top, and that would be our 1 meter. Okay, so we multiply that through and we get 45.72 divided by 100, we get 0.4572. That is not 4 meters, so he's not going to be able to complete his circuit. What you have on the screen now is a more standardized chemistry problem, something to do with solutions and densities. These ones you'll do more often in the chemistry classroom. And if you'll read, you'll see that Jeff is currently working as a marine biologist. It's great, but it's not really doesn't really have anything to do with what we're covering right now. But Jeff's working as a marine biologist. At the moment, Jeff is trying to dilute a solution to the point that dilute a solution of acid. He knows he needs 5 liters of a pure distilled water to achieve the desired pH. However, he has no volumetric tools. That means he has no graduated cylinders, he has no beakers, he has no Erlenmeyer flasks. He does, however, have a scale. And using that scale, Jeff can work through and find the mass of the water he needs, because he knows that the density of water is 0.95 grams per milliliter at room temperature, which, since it doesn't say that it's freezing or the temperature, you assume room temperature. So here's your equivalency. We know that 0.95 grams is equal to 1 milliliter. We know this because grams per milliliter is a ratio, and it's an equivalency, just like we've been using. And we know that he needs 5 liters. Okay? So we need to convert our 5 liters into milliliters using another equivalency, and then our milliliters into grams. Now, one liter is 1,000 milliliters, thus the prefix milli. So, once again, we draw a ratio line. We put what we have, which is liters, on the bottom, and we put what we're converting to on the top. We then, using another conversion factor, put what we need, our 0.95 grams, on the top, and then we convert from our milliliters on the bottom. This allows us to go through and cancel our units. Liters are gone, milliliters are gone, that leaves grams. So if you do some math, 5 times 1,000 is 5,000. 5,000 times 0.95 is 4,750 grams. And that's how many grams he needs. So this is a basic dimensional analysis problem you would perform possibly in the chemistry lab. This concludes the lecture on topic 1. Possibly in the future we might post some supplemental videos, some practice videos, some problem solving videos, but this is the final lecture video on topic 1. Thanks for watching, and hopefully you'll tune in for topic 2, the atom.